And product property talks about the product of two logarithms. All right, so a log, we'll use the letter A. Plus a log of the letter B, plus a log of the letter C is equal to a single logarithm where you multiply A, B, and C together. So long as the bases are the same. That's kind of a big deal. Bases are the same. And you could have a fourth logarithm or a fifth logarithm or a sixth logarithm. Or you just have two. Okay? Doesn't matter. The logarithms are inverses of exponential functions, so this kind of makes sense. When you multiply like terms, what are you supposed to do with the exponential space? Add it. And that's kind of what's going on here. So log base 6 could actually be broken into two distinct logarithms. You can have log of 2 plus log of, actually, let me rewrite this quicker. What are factors of 6? Let's go with 2 and 3. You could do the number 6 as 2 times 3, right? That means you could break that logarithm apart into log of 2 plus log of 3. This may not make much sense to y'all as to why we do it. It actually goes way, way back in about 1600s when they actually used what we called logarithm tables. You might not have log of 5,640 in there, but you could break that apart and look at your log tables. Or they had smaller numbers. Then you could add the stuff together. Product properties about addition becoming multiplication. Quotient properties are going to be about division. And I'll write this one out a little bit different. I'll do the division first. Let's say we have a natural log, and I'll use ln just because. A times B sitting over C times D. So natural log of AB sitting over CD. Now that is equivalent to the natural log of AB minus the natural log of CD. Think about when we're working with exponents. When we divided like terms, when we do the exponential space, we subtracted, didn't we? So it's kind of the same rule of logarithms. Now we actually can take this a step farther. The natural log of AB can be broken apart into two logarithms. That's a product of two things, isn't it? So that's the natural log of A plus the natural log of B. And then this take away stuff. I can take away two things there. I'm actually taking away two things, right? Minus the natural log of C, minus the natural log of D. Because I took away all of that. I have to take away both pieces. Now, a big thing here is when you're working up top, you just look at your logarithm. The top is addition. Anything behind the bottom is what? Subtraction. That's as simple as you can get. Top is addition, bottom is subtraction. Every time. Every time. All right, we got log of 5 over 2. How can we break that apart? Log of 5. I think I heard Christina say it. Log of 5 what? That's division. Minus log 2. We have the power property. A logarithm with some argument A and some exponent R is equivalent to R log A. And I might have like base B down here. It's just quicker in the notes not to throw that there. So this is telling us that I can take those exponents and I can move them out front. That's all it's telling us we can do. So we have a simple example here, log base 10, because it's understood, 5 squared. Where's that 2 go? Yeah, so down here? Yeah. B for base. Anyways, you guys said I can throw that 2 out front. 2 log 5. Those are your 3 properties of logarithms. That's all we talk about today is those 3 properties. And they will be on your next formula quiz, which is going to be quite a doozy. We were up to what, 43 before the break, and then everybody went into quarantine nonstop, so I quit giving them. You're at least 60 by now.
I just started doing good on Mustangs. Everything went good.
I can't help it, man. I couldn't get over quarantine.
Why not? I could have cheated them real good. Real good.
And the sad part is half of them would have done it. They wouldn't even been half.
Well,
It's been really low. All right, expand the given logarithm. That means that we break this thing apart, express all powers as factors. So you have log base 6 of 9 times x squared. You see that? Now look at the notes you just took. How do you break apart multiplication? Through addition. Okay. Well, it is in 2 distinct steps. Go ahead, Sam. Tell me what you're thinking.
Log base 6 of 9, log base 6 of x squared.
I'm good with that. But you're not finished. He did the break apart right. That's right. He's just not finished. There is still something else that can be worked with. Look at that power property. There you go. That 2 can run up front. This thing's fine. Log base 6 of 9 plus 2 log base 6 of x. You guys got any issues with that? Again, it's just a property. Apply the property. Get that property in. That is the final answer. That's called an expansion because look at it. It was something small and now it's something bigger, right? Expanded, broken apart. A b is a natural log of 8 divided by 3y1/2. So this is kicking in division, quotient. How do you handle division? Subtraction. So somebody give me something. Somebody besides Sam, tell me what to write.
Ln of 8 minus ln of 3y1/2.
Natural log of 8 minus natural log of 3y⁻². Now, some kids are tempted to break these 2 things apart through addition, but you're taking away all of them, aren't you?
Yeah.
Every bit of this from all to the right is going to be about subtraction. Just keep that in mind. You can still break apart natural log of 3y⁻². Even more than that. I mean, I'm good with that. But actually, that's wrong. 3 doesn't have half power. Y does. So minus natural log of 3 minus natural log of y to the 1/2. And you can still break it up, right?
0.5.
You can use 0.5. Bring that half out. Now, when I do these problems, I don't show all this work. It's a one-step thing. I'm trying to show you guys all the individual thought processes. Because Sam, he jumped to a conclusion. He saw a half power and wanted to throw it out front. But it wasn't attached to 3. So you're still going to have to break these things apart before you start doing exponents. Let's see. 4 square root 6x plus 3 sitting over 4y squared. Before we even start on this thing, square root, what's its power? 1/2. If you don't understand the square roots of the 1/2 power, I don't say this mean, do not take pre-calc. If you don't understand something is understood as a square root being 1/2 power, do not take pre-calc, kids. I see this every year, kids show them pre-calc, and I'm like, what the deuce are you doing here? But whatever. I'll try. That 6x plus 3 is raised to the 1/2 power. And it's sitting over a 4y squared. I wouldn't break this thing apart just yet. Why wouldn't I? This is what I'm telling you. Think, why wouldn't I break this thing apart just yet?
The square.
No, those are different terms. One's x, one's y. There's 4. There's 4 up top, 4 down low. What can you do with it? Get rid of it. Do a simplification of the intermediate step. It'll save you time. That's one less thing, actually, it's two less things you gotta write down, right? Now, the top is about, actually, there's not a whole lot more up top. There's no product of two things anymore. This would be the natural log of 6x plus 3 to the what? Where's that half go? In front. 1/2 natural log of 6x plus 3. You'll need a set of parentheses on that because there's two on there. And then there's something down low. What do we do with that stuff down low? Subtract it. You think in your head, you visualize in your head on that little empty piece of paper you got up there, minus natural log y squared. Well, where's the 2 go? Up front.
That's 6x plus 3.
It is 6x plus 3. Minus 2 natural logs of y. And that's all we're going to do on the expanding. So what's up next in your note should be a condensing. Was that the one? Is it not a condensing?
It's the one after this
Next
section.
line.
Oh, I was hoping condensing was next. Or is this this is ACT stuff. You're going to take that thing on the second. Yeah, y'all are in trouble because we haven't really trivia.
Can we just like?
So got going?
You said what?
Usually at this point in time, we are in unit 13. What unit are we in?
7.
COVID.
No, it's not COVID. It's
Pretty dumb.
you're slow. You don't care. I use the fact that log base 6 of 5 is 898 thousandths, and log base 6 of 8 is 1 or 161 thousandths to evaluate the following. This is more how we used to do things before technology really came into play. I remember doing a lot of this as a kid. A is log base 6 of 5 over 8. Now, how do you break apart 5 over 8? Subtraction. You need to see that. This is equivalent to a log base 6 of 5 minus a log base 6 of 8. And look above. Do you actually know those values?
Yeah.
You do. You can replace log base 6 of 5 with what? 898 thousandths. What can you replace log base 6 of 8 with? 0.161. Now, 898 is 102 from 1,000. 161 to 161 from 1,000. There's a reason I'm thinking like that. Anybody know why? Because 102 plus 161 is 263. Negative 0.263. Quicker than y'all can take the calculator. I centered around 1,000 because it was thousandths. Anyway, that's how I do stuff in my head. B, log base 6 of 40. I want to break this thing down so that I see things about 5 and 8. 8 times 5, that's right. Think about what 40 is. It's 8 times 5.
Multiplication, you can add it together.
That's right.
Log of 8 plus 5.
Log of 8 plus log of 5. So we got our 1.6161. I'm going to add to it that 0.898. How do we get there? 0.959.
I got 0.59.
Yeah, that's right. Log base 6 of 125. You may not be able to get there with both of them. 5 times 5 times 5. Or in other words, 5 cubed. Nothing wrong with your route, Christina. Christina says log base 6 of 5 times 5 times 5, which is fine. It's correct. I'm suggesting an alternate route because it's a little bit quicker, and Sean mentioned it too. That's a 5 cubed. Where's the 3 go? In front. 3 times log base 6 of 5. What is log base 6 of 5? 0.898. So 3 times 0.898. 3 times 0.9 would be 2.7. I have to take away this 6 of that. So 2.694 is correct. That's how we used to do some of this stuff by hand. I was just on the verge of this. We spent a day or two doing this stuff by hand, and they show us how to do it in the calculator. Had I been 10 years older, I would have done all of it by hand. So I'm just old enough to have a mix of the old and the new. So that's so bad? It's probably a lot harder on your homework. Usually is, isn't it? Well, there's a reason for that. You only grow if you struggle. It's the only way you grow. All right, condensing into a single logarithm. We've got all these, by the way, are log base 5s on A. All of them on B are log base 4. That's a big deal. You can only condense or expand if they're the same base. Now, we've got a little mixture of everything going on A. We've got a first logarithm. By the way, what's the sign on that first logarithm? Is it positive or negative? Positive. It is a positive logarithm. It's kind of a big deal. I'm going to go ahead and put that positive symbol there. And the one in the middle is negative. Now, before I do anything, I'm going to think about a particular property. Log base b of a to the r is r log base b of a. This needs to be done first.
4x.
That 2 needs to be moved up. And it's 4x all squared. Both pieces, not just one, it's both pieces. Don't put it with just the x. So we have 2 positive logs. Those are the logs that would be added together. How do you add logs together as a single logarithm? Multiplication. Right. A single logarithm. In that logarithm, we have x squared plus 4 times the 3 because they were positive. And then we have the subtraction. Well, subtraction is what? Division. So we throw that over a 4x that is squared. Let me do a little erasing right here. That's your logarithm. Log base 5 inside that in the numerator is your x squared plus 4 times 3. Down low, a 4x that has to be squared. You're not done with this thing. All you've done is the initial condensing. You haven't done any simplification yet. That's always one of the things that gets kids. All that simplification. What is 3 times x squared plus 4? 3x squared plus 12. Down low, what do you get when you square 4x?
16x squared.
Are you done with this thing?
No,
Why not?
there's a 3x squared and 16x squared.
I know you're done. It's a trick question.
You
You can't simplify x squareds. Do all 3 pieces possess an x? Only 2 of the 3 pieces possess an x. You can't throw away x's, kids. It's all or nothing. Are all 3 pieces divisible by a particular number? No. This thing is done. You can't do any more simplification. Done. All right, B, we got half log base 4 5x plus 3 log base 4 2 minus log base 4 of 8. Actually, how much time we got left? We got one more slide after this, right? This one? Okay, we're good. It's a word problem, so I don't care if we do it or not. Where's that half go? Exponent. Right there. Log base 4 of 5x all to the 1/2. Where's that 3 go? Not behind the 2. Above the 2, right? A cubit. I'm a big fan of simplification. What's 2 cubed?
8.
Why did I write that out? Log base 4 of 5x to the 1/2 power. Full condensed. Hopefully you got a homework assignment too.
For your final answer, do you write it to the 1/2 power or do you square it? Or does it matter?
1/2 power. You put with the square root symbol, but it should be 1/2 power.
For some reason, this log stuff is easier than we were doing before this.
Logarithms are hard. They're really not.
Yeah.
Anyways, we'll go ahead and sign it tomorrow. Enjoy the rest of your day. Hurry up, wake up. Did I not record?